what you should expect in the exam. Okay. All right. Don't worry, we'll be fine. Let's assume that price of X is 5 cedis. Price of Y, PY is 10 cedis. Income of the consumer Y is 100 cedis. It's not 100 cedis, so it's 100 cedis. Normally in Ghana, they will say, oh, 100 cedis. When they say 100 cedis, they are referring to 100 cedis. But if you say 100 cedis, it is 200 cedis for 300 cedis. There's nothing like 100 cedis. We have 100 cedis, 200 cedis, 300 cedis. Okay, so then it's a point that when you say 100 cedis, people should take it as 100 cedis. No. 100 cedis could be 300 cedis or 500 cedis. Okay? All right. And also remember, any number after the decimal point is less than 1. So you don't pronounce it as, for instance, in full. If you have something like this, 0. What? This is 0.25, not 0.25. Excellent. And this is 1,000, not 1,000. Okay. This is 1,000, not 1,000. Okay. So if you are given the full information together with your model, the question now is, what is the price elasticity of demand for commodity X? Calculate the price elasticity of demand for commodity what? X. So in this question, as I told you the other time, the amount of information provided in the question will tell you the type of formula to use in calculating your price elasticity of what? Demand. So in this case, there's no percentage change in demand, and there's no percentage change in what? Price. So obviously, the other formula is what we are supposed to use. And that formula is change in quantity demanded for product X over change in price of product X times initial price of product X over initial demand for product what? X. Good. Last week, we indicated that this change in demand for X over change in price of X is the slope or the coefficient. And so to find that coefficient or slope is to differentiate your demand function with respect to what? Price of X. With respect to what you have in the denominator. And so our change in quantity demanded for product X, QDX, over change in price of X is the same as the QDX over the PX. The D here just represents this change symbol. Okay, so it's the same thing, just a mathematical way to frighten people. Okay, so this will give us, we have to differentiate this with respect to what? Price of X. And as I said, to differentiate any model, you have to differentiate, identify each term in the model. So in this particular model, we have various terms. We have 15, we have minus px, we have positive 10,000 watts y, then we have minus 10p y squared. Okay. Now, because our interest variable is px, if you are differentiating this model with respect to px, any term in the model without px will be deemed to be a constant. And differentiating a constant will give us what? 0. So let's start. Change in QDX over change in price equals the first term. Does this have px? No. So we consider that to be a constant. And differentiating a constant will give us what? 0. The second term, we have minus 5px. Does this have px? So there is px in that particular term. And so to differentiate it with respect to px, is to take the power of the px here, which is what? 1. Because any number standing alone is to the power 1. So take that 1, multiply by minus 5px. And that will give us minus 5px. Then you complete the differentiation by subtracting 1 from that one. And 1 minus 1 will give us what? 0. So what we are going to have left is going to be minus 5px to the power what? 0. And any number to the power 0 is what? 1. 1 times minus 5 will give us what? Minus 5. Okay? Very, very simple. Then we have the next term, 10,000y. To differentiate 10,000y with respect to px, the question is, does this particular term contain px? No. So we consider this whole term as well to be a constant. And differentiating a constant will give us what? 0. So we move on. Here we have minus 10py squared. Does it contain the term px? No. So we consider that term to be what? A constant. And differentiating it will give us what? 0. So here our change in qdx over change in px equals to what? Minus 5. All right. Then that means in this particular formula, we have been able to find the value of the slope, and that is minus what? 5. The next is the px. What is px? We have been told px equals to what? 5. Then we have qdx. What is qdx? For now, we do not know, but we know that qdx equals to this. So in place of these unknown variables, we substitute these values for them, so that our qdx will equals to, we have 15 minus 5. Our px is what? 5. Plus 10,000. Our y is what? 100. Okay. Then minus 10 py what? Square. And that's py is what? 10. So we put 10. The number is what? Square. Excellent. So we have 2bx equals 15 minus 5 times 5 gives us 25 plus 10,000 times 100 gives us what? It gives us 1 million. Okay. 1 million. Then 10 squared gives us what? 100. 100 times 10. It gives us 1,000, not 1,000. So minus 1,000. Very good. So this gives us 15 minus 25 will give us minus what? 10. So minus 10 minus 1,000 will give us minus 1,000 and what? 10. So we subtract minus 1,010 from 1 million. And that gives us what? 900 and what? Where? Here? We are doing a subtraction. Are you okay? So this is our demand for X model. And when we find QDX, we have to substitute the value for this in this formula. Because in the formula we're calculating price elasticity of what? Demand. And so to do so, we have been given the question, the values of Px, Py, and Y. So we substitute these values in place of their variables in the regression model. This has given us this, where we have the 15 minus 5 into brackets, the Px, which is 5, we have it here, plus 10,000 into brackets, Y, which is what? Giving us 100. So we have it here, minus 10 into brackets, we have Py. Py is what? 10. But remember in the equation, it is Py squared. So we square this particular what? 10. And that is why we have minus 10 into brackets, 10 what? 10 squared. Are we okay? All right. So we then do the arithmetic, the addition and what? Subtraction. Okay, so when you subtract this minus this plus this minus 1,000, what will that give us? 998 990. Very huge value. So this is our quantity demanded for product at what? X. So we now come back to your demand, elasticity of demand formula. we know that from what we have done, our price ratio of demand therefore is going to be, the slope here is what? Minus 5. The price of x is what? 5 divided by the QDX, which we have calculated here, is what? 998,990. Okay, so 5 is over 1. So minus 5 times 5 will give us minus what? 25. 1 times 998 will give us 998,99 what? 0. So when we divide, it's going to give us what? As we did yesterday. Yes, that's right. Yeah. This way? That's in this way. Yeah. Yes. Lines up. Yes. And the mic is this way. I think that is it. Let me hang it this way. It's okay. Okay. All right. Good. So what is our final answer? Negative 2.5. Negative 2 point what? 2.5. That's minus 25 divided by 998,990. So that gives us negative 2.5. Hello? Times, that gives us what? Times 10 will be. Okay, times 10 minus what? 5. Okay. So it's quite an arbitrary number. That means the answer is 0.5 zeros before 25. Okay. Sorry, 4 zeros, yes, before 25. So that is virtually equals to 0. Okay. That means our price ratio of demand is equals to what? 0. Okay. In 2 or 3 decimal places, it's going to be equals to what? 0. And when the price ratio of demand for the product is equals to 0, how will you classify that product? Does it have elastic, perfectly elastic, or perfectly inelastic demand? Perfectly it's perfectly inelastic. Inelastic. Because when the coefficient of the price ratio of demand is equals to 0, it simply suggests that the consumer does not respond to changes in what? Price. Its responsiveness is 0. Okay, that is the meaning. Its responsiveness equals to what? 0. All right. So from this, we can also ask you to calculate the income elasticity of demand. In that case, our income elasticity of demand will be equals to change in quantity demanded for products X over change in income of the consumer of the product X times initial income over initial what? Quantity demanded for product X. As we need to find the slope for product X price, so should we also do to find the what? The slope of the income of this particular model. So let's go ahead and do that. I hope I can claim this. So our change in quantity demanded for products X over change in income will be equals to the QDX over the what? The Y. And that equals to. So let's do the differentiation once again. This time, we are differentiating QDX with respect to what? Y, or income. So as I said, you have to identify the various terms in QDX. So we have 15 and all that. So let's start. Do we have Y in this term? No. So we consider that term to be a constant. And differentiating a constant will give us what? 0. Here we have minus 5px. Do we have y in that term? No. So that also gives us 0. Here we have positive 10,000y. There is y in that term. So we can differentiate that term with respect to what? With respect to our y. How do we do so? We take the power of the y, which is 1, multiply by positive 10,000y, and subtract from that 1, the power of y, 1. And that gives us what? 0. Then we are left with y to the power what? 0. Any number to the power 0 is what? 1. 1 times positive 10,000 will give us what? Positive 10,000. Okay, so we have 10,000. Then the next term, or the last term, is what? Minus 10p square y. Do you have y in that term? This y is product y, not income. Not capital Y here, as we have it as income. So there is no y in this term. We only have price of product what? Y, which is not the same as income y, that we are differentiating the model with respect to. And so here there is no y. So that also gives us what? 0 when we differentiate it. And so we are going to have our change in QDX over change in y to be equal to what? 10,000. So we come back to our formula for calculating the income elasticity of demand and say that it is equal to 10,000 times initial income of the consumer is what? 100 divided by the initial quantity demanded for product X, which is what? 998,990. Okay, but we know that this 10,000 is also over what? 1. So we multiply 10,000 by 100 and multiply y1 by what? 998, and then do the division, and that gives us 10,000 times 100 will give us what? 1 million. So you see that we said 1 million, 2 million, 3 million. We didn't say it will give us million. No. So there is no thousand. We have 1,000, 2,000. I was expecting somebody to say it will give us million. Then I'll ask what is million. So 1 times 998,990 will give us 998,990. So dividing 1 million by this will give us 1.00 in 2 decimal places. So we have 1.00. So you see that it is virtually equal to what? 1. So when your income elasticity of demand is positive, how will you classify the product? Already we said that the product is what? Normal or inferior good? It's a normal good. And that is why the coefficient here, when we calculate it as the coefficient for income elasticity of demand, it is positive. Okay, and once it is positive, it means the good in question product X is a normal good. Very good. But if we want to devalue a little bit, last week we said that when the income elasticity of demand is calculated and the value, we expect that to be positive, all right. But if the value is 1, then we say it's a normal what? Good. When the value is positive, in other words, it is greater than 0, but less than positive 1, then we say that it is what? A necessary good. But when the value is more than 1 and it is positive, then we say it is what? A luxurious what? Good. However, when the value here is negative, it means the good in question product X is what? Is an inferior good. So anytime you calculate your income elasticity of demand and the value turns out to be negative, then the good in question is what? An inferior good. And you can see that already from the model as we did. Okay, when the coefficient of income is negative, the good is an inferior good. When it is positive, the good is what? A normal good. They are good. I think we can continue. Last week can I clean this? Okay, so let me make an appeal. We will actually have to speed up a little bit. From next week, after our meeting next week, we are expected to go online, right? Yes. And you can imagine what going online with this course will be. Uh-huh. So, yes. Try this minus 25 divided by this. Yes. So that means you have four decimal zeros before the 25. So we have 0.000025. Yes. So let's convert it to 0. Yes. So yes, when the price of Y has an inverse relationship with the demand for X, then it means the two probabilities X and Y are complements. Say that when the price of, let's say, Y is petrol, X is a car. When the price of petrol is increasing, then the demand for cars will be what? Will be falling. And so that means car and petrol will be what? Complement, yes. So we need to speed up a little bit so that should we go online from after next weekend? After next weekend, should some of us be unable to come in person, we'll be available to have the lectures in person. So that those who are around and can make themselves available, they can come. Because we understand the nature of the what, the nature of the course. But those who will not be able to come and will have to be online, we will have to speed up to cover certain things that are a little bit technical before we go online after next what, weekend. So just permit me to be a little bit fast as we cover some of the issues. Let's look at this question. Let's look at this question. I can clean this now, right? Okay. So let's look at an example, one more example on illustrated, and then we can proceed to some other interesting issues. Assuming that we are given the following demand function, QZ equals 100 minus 5P, and we are told that the price per sale demand equals minus 1. What are the corresponding price and quantity demanded for the product? What are the corresponding price and quantity demanded for the product? So we have to find QD. So let's say this is QDX, DX. So we are dealing with product what? X. So we have to find the price of product X and then the quantity demanded for product what? X, given this information. How do we find that? So we are giving the price last year of demand to be equals to minus 1. And then we know that the price last year of demand equals to change in quantity demanded for product X over change in price of X times initial price of X over initial quantity demanded for product what? X. All right. And then we know this to be the what? The slope. And so if you have to find the slope, is to differentiate this function with respect to what? Px. And having done a series of them, what will be the slope in this particular case? It's going to be what? Minus 5. Because when we differentiate this function with respect to Px, there's no Px in 100, so it's a constant 0. Here we have minus Px, 5Px. To differentiate this, take the power of the Px 1, multiply by this, and subtract from that 1, and that gives us what? 0. So Px to the power 0 is 1. 1 times minus 5 will give us minus 5. So in place of this whole expression, we have minus what? 5 times our price Px is what? We have not been given. That is what is part of what we are supposed to what? To find. So we have 5 times Px over what? Our QDX. However, we know our QD what? Our QDX. And what is our QDX? Our QDX is given us this. and it is what? 100 minus 5p what? X. And we know that this number is also over what? 1. So to proceed, we have minus 5 times px, and that gives us minus 5px divided by 1 times this in brackets. We have 1 times this is going to give us this. So we are going to have 100 minus 5p what? X. But we know that on the left hand side we have price elasticity of demand. And we have been given that to be equal to what? Minus 1. So in place of this, we put minus 1. And that minus 1 is also over what? 1. So to find Px, which is what one of the things we are expected to do, is to cross multiply. So we cross multiply this by this, and then that's by this. So 1 times minus 5px gives us minus 5px. And that's because negative 1 times 100 minus 5px is going to give us what? So let's expand the bracket. So we have minus 5px equals this times this 100. This times this will give us plus 5px. To find px is to sign like thing. So we take minus 5px across and take the 100 minus 100 to the other side. So minus 100 crossing the equal sign gives us 100 equals positive 100 equals 5px plus 5px. 100 equals 10px. To find px, divide here by 10, here by 10. Our px will be equals to 100 divided by 10. And that gives us what? 10 Ghana cedis. So we can then go ahead to find QDX. How do we find QDX? Now that we know PX to be 10 Ghana cedis, we substitute that in this model or equation. And doing so, we have Q dx equals 100 minus 5px. Our px is what? 10 Ghana cedis. So we have Q dx therefore being equals to 100 minus what? 50. So our Q dx is equals to what? 50 units of the commodity. All right, very, very good. Again, let's look at a diagrammatical illustration of what we did last week when we talked about the relationship between price elasticity of demand and then total revenue. Last week we talked about the relationship between price elasticity of demand and total revenue. Are we good to go? You are staring me because what is coming, I don't know why. You are already worried with this one. All right, I think we can go ahead. So price elasticity of demand and total revenue relationship. So let's look at this. Last week we indicated that the total revenue a firm is able to drive equals to what? Price times what? The quantity of the products that the firm is able to what? To sell. So the number of units of the product we are able to sell times the price per unit of the product will give us the total what? The total revenue. Then we indicated that when the price elasticity of demand for a product is that the product is having an inelastic demand, and you increase the price of the product, will it increase your total revenue or it will decrease your total revenue? If the price elasticity of demand for a product is inelastic, inelastic means that the responsiveness of the consumers to the changes in price for the product is what? Is zero. So in that case, when you increase the price of the product, will the increment increase your total revenue or it will reduce your total revenue? They will respond to the changes in price. So when you increase the price, no matter the price, they will still buy. And so when you increase the price, the total revenue will also increase. However, if the price ratio of demand for the product is elastic, means that marginal increments or small increments in the price of the product will lead the consumers to decrease their demand for the product more than proportionate change in what? Price. In that sense, the manager of the firm should stay away from increasing the price of the what? Of the product, as that will reduce the quantity demanded for the product more than the percentage change in what? Price, thereby reducing the total what? The total revenue of the firm. We want to look at those interesting relationships or patterns, and in doing that, we want to look at that in the context of some diagrams. All right, we can take this. So let's start. So this is our price axis, our quantity axis. This is our demand curve. All right. You can see that the demand curve in this particular situation is very steep. And what does it mean? The steeper the demand curve, the more price what inelastic the demand for the product will be. The more price what inelastic. The steeper the demand curve, the more price inelastic will be the demand for the what? For the product. So let's illustrate that with more more information. So let's say the initial price of the product is P1. And at P1, the quantity demanded for the product, tracing the price P1 to the demand curve, will give us the quantity of the product that is demanded at price what? P1. Assuming for a minute that the price of the product increases from P1 to P2, tracing that to the demand curve will give us a quantity Q2. Meaning that when the price increases from P1 to P2, the quantity demanded for the product will fall from Q1 to what? To Q2. But we can already see that the margin of change in the price from P1 to P2 compared to the margin of change in the quantity demanded for the product, we can realize that the margin of change in price is far greater than the margin of change in what? In quantity. And that means the price ratio of demand for this product is inelastic. Meaning that even though the consumers respond to changes in price from P1 to P2, their responsiveness is not equal to that of what? The change in the price. Because their response is just by this change in quantity compared to this amount of change in what? Change in price. So initial total revenue, let's call that TR1, was the price initially times the quantity that was sold at that price. And so the initial price was P1, and the quantity sold at that P1 price was what? K1. So this represents our initial total revenue as a firm, because we know that total revenue equals the price times the quantity that we sell. Following the increment in price from P1 to P2, our total revenue will now change. So total revenue, the current total revenue TR2 will therefore be equals to the current price times the current quantity that is sold at that particular what? Price. So it's going to be P2 by Q what? Q2. So meaning that, is there an increase in revenue or a decrease in revenue? There's what? A decrease in revenue. So let's look at, there are two things. There's a decrease, yes. So following the increase in the price of the product from P1 to P2, leading us to have only Q2 demanded for the product, it means that our total revenue will now change from the initial TR1 to TR2, where the TR2 will be calculated by the current price P2 multiplied by the current quantity demanded, Q what? 2. And that is our current total revenue, TR2. Yes. The decrease in revenue. Yes. Somehow, because the increase in price is far more than the decrease in quantity. Yes, yeah, so we have not concluded on that. So, yes, I was also explaining that, then somebody asked a question. So let's continue. So when there is a price change, there will be revenue loss and revenue gain. How much are we going to lose? This quantity was what was demanded initially. Now, following the increment in the price, this is what is now what demanded. So this amount has been lost. This amount of the initial revenue has been what? Has been lost. So we call that RL, revenue that is what? Lost. But following the increment in the price from P1 to P2, there is an additional increase in revenue. So we call that revenue what? Gain. So from P1 to P2, multiplying that by Q2 has given us the TR2 as our current what? Total revenue. So this is the P1 to P2. This area here is the revenue that is what? That is gain. Okay. So the net effect is what we are now interested in. You see that the revenue that is gained is greater than the revenue that is what? Lost. So when the demand for the product is inelastic, is price inelastic, it means that increasing the price of the product will give you increase in what? Total revenue. All right, very, very good. Then let's move on to another example. This is our demand curve. Our price as is P, our quantity as is Q. All right. Let's assume for a moment that initial price of the product is what? P1. And if you trace the P1 price to the demand curve, we get our Q1 as our initial quantity demanded for the what? For the product. Due to certain happenings within the economy, the price of the product has increased from P1 to P2. And as a result, the demand for the product has fallen from Q1 to what? To Q2. We can see that the change in quantity demanded for the product compared to the change in the price of the product, they do not match. Following the marginal increment in the price of the product, the percentage change in the quantity demanded is far greater than the percentage change in what? In the price. And so when it is like this, we say that the price versus demand for the product is relatively what? Elastic. So this was relatively inelastic, and this is relatively what? Relatively elastic. Okay, relatively what? Elastic. So when there is a small change in price, it brings about a more than proportionate change in quantity what? Demanded. Okay. All right. So let's do our interpretations once again. So initial total revenue of the firm was TR1, and that was equals to the initial price 1 multiplied by the initial quantity that was what? Sold. And so it was P1 multiplied by what? By Q1. Now, following the increment in price from P1 to P2, quantity has fallen from Q1 to Q2. So our total revenue TR2 would therefore be equals to P2 times Q2. Again, we have lost part of our total revenue, and that is here represented by RL. But following the increase in price from P1 to P2, we have gained this amount of what? Total revenue. So you can see that our revenue loss is greater than our revenue what? Gain. So when the price as well demand for a product is relatively elastic, it doesn't make sense for the manager of the firm to want to increase the price of the what? Or the product. As a marginal increment in the price of the product will bring about a reduction in the total revenue of the what? Of the firm. Another one. Assuming this time we have a normal demand curve. So our price as this, and then our quantity axis as usual. So we have this. All right. Not as perfect as I want it, but let's do it now because there's no time. So let's say initial price was P1, and at P1, quantity was what? Okay, so let me polish that up a little bit. Initial price was what? P1. And at initial price P1, quantity was Q1. Again, following certain happenings within the economy, the manager finds it necessary to increase price from P1 to P2. And that has resulted in a decrease in demand from Q1 to Q2. All right. So we can see that there is a revenue gain and a revenue what? Revenue loss. So, and you can also see that the change in quantity in this particular case is virtually equivalent to that of the change in what? Change in price. And so our revenue gain is RG here, and our revenue loss is what? RL here. So you see that basically, more or less, our revenue gain is the same as our revenue what? Loss. And that tells us that this product has unity price what? Elastic demand. So the demand, the price elasticity of demand in this particular case is what? Is unitary. When the price elasticity of demand for a product the manager sells is unitary, it means that whether you increase the price or reduce the price, total revenue is going to be what? The same. And so the revenue gain minus the revenue loss is going to be zero. There's not going to be a decrease or an increase in total what? In total revenue. Because a 5% increase in price will result in a 5% reduction in total what? Sorry, reduction in what? Demand. And so therefore, total revenue will remain what? The same. Okay. If you have a perfectly, there is our demand curve, our quantity axis, our price, 0. So here we have price P. 1. Let me explain this as the last one. So let's look at this as well. I'll go back to that. Okay. This is our demand curve, our price axis, our quantity axis. Okay. So assuming that the price of the product initially was set at P1. At that P1 was what? Was demanded. And so total revenue of the firm TR1 was equal to P1 times what? Times Q1. Then the manager decides to increase the price from P1 to P2. And realize that at the same price, at that high price P2, the same quantity Q1 is what? Is demanded. Meaning that the current revenue, total revenue of the firm is going to be P2 times what? Q1. Because despite the price increment, the same quantity is what? The same quantity is demanded. So this is our revenue. So we have a situation like this. Irrespective of the changes in price, the quantity demanded for the product remains the same. We describe that as what? The product as having a what? A perfectly what? Inelastic demand. Perfectly inelastic demand. Meaning that the responsiveness of the consumer is totally zero. So it doesn't respond at all, irrespective of the changes in what? Changes in price. So in that case, when the product has perfectly inelastic demand, it makes sense for the manager to always increase the price of the what? Of the product. As increments in the price of the product will allow what quantity demanded for the product to remain what? The same. Okay. So in this case, we only have revenue that is gained. We don't have any revenue losses. And so it's good to sell a product that has perfectly inelastic what? Demand, as that can easily make you profit as a firm. So this is the case of perfectly inelastic. Okay. Then the last one. The last one. In exam, I'll send the past questions to you. Okay, with the illustration of diagrams indicates the relationship between total revenue and price elasticity of demand for products so and so. Given that the manager informs you that the demand price elasticity of demand for the product is relatively elastic, relatively inelastic, unitary, elastic, and all that. Then you now pick one of these as your correct answer. But the way I'll show you is going to be very beautiful. So when I send the first questions, carefully go through the questions. You'll be proud of yourself when you answer those questions. Very interesting questions. And so let's look at the last component of it. This is the case where initially the price of the product is set at P1, and let's say K1 of the product is what is demanded. Then the price increased from P1 to P2, and 0 is demanded. So our initial total revenue TR1 will have been calculated by multiplying P1 by Q1. And so that will give us P1 times the Q1. Now we decided to increase the price from P1 to P2 and realize that the quantity demanded for the product is now equal to 0. It means that this particular product has perfectly what? Elastic demand. Meaning that a small increment in price will result in a total abandonment of the what? Abandonment of the product. Nobody will buy the product altogether. And so that it means when there is a marginal increase in price from P1 to P2, you are going to have revenue loss and none of revenue that will be lost. That will be gained. And so our revenue loss will be RL here, and there is no revenue loss, revenue gain. So we are only going to have revenue loss. And so this is a case of perfectly elastic demand. Perfectly elastic demand. So thankfully we have brought that session to an end on the price elasticity of demand. We want to start our topic for today. Now, if perfectly elastic and inelastic is still confusing you, when you draw the diagram like this, when you mentally connect a line, a vertical line here, you see that it looks like an E, and that is perfectly what? Elastic. And this looks like an I, and that is perfectly what? Inelastic. So should the diagram stop confusing you, you can use this simple trick to always find your way out. Yes. Yes. Perfectly inelastic. We all know that petrol is one of them. Yes. All necessary goods tend to have perfectly inelastic what? Inelastic demand. And all auxiliary goods tend to have perfectly what? Elastic what? Demand. And all normal goods tend to have unitary what? Elastic demand. Okay. As with the specific examples of normal goods, normal goods, necessary goods, and luxurious goods, as I said, it varies from person to person, society to society. What you do as a normal good to somebody is what? A luxurious good. And somebody's necessary good is somebody's luxurious good. And somebody's inferior good is another person's what? Normal or luxurious what? Good. Excellent. So let's continue. Today we want to look at a theory of consumer behavior or utility. Yep. Sorry. Yes. I've not shared the slide with you. Let me WhatsApp to you. I hope I can claim this. And switching.
But I don't have this slide. I'll have it.
I think you don't have it. I have to send it to you. Any questions? Okay. Okay. Yes. Yes. Demand curve moves downward from left to right. Yes, we said that. So we have different types of demand. Okay. We have different demand curves depending upon. So the shape of the demand curve will tell you something about the price and of demand nature of that particular product. So the unitary elastic demand will have a normal demand was curve. Yes. 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 Yes, but we have some exceptions. In other words, some types of what? Some different types of demand curves. Okay. Are we together? Different types of demand curves whose shapes are informed by their nature of price or elasticity of demand. So if the demand for a product is unitary price elastic, then it has a very normal demand curve. But if it is perfectly elastic, then it has this type of demand what? Curve. So it's not in all instances that the demand curve must necessarily slope from a downward from left to what? To right. Because there are different types of demand curves based on their various types of what? Price elasticity of demand. All right. Thank you. Let me quickly share my network. Any other questions? Very interesting concept. So as we go through this, let's be thinking about how we can apply them. Not necessarily at work. Somebody normally after class, some people will come to you and say, "Oh, with the work they are doing, they don't require these things." That's okay. Yes. He said demand. Yes. 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 So because of the lack of time, if you have something like this and it is a supply. The same thing is reflected in the supply analysis. Because of the lack of time, that is why we have not gone into that. So this would have been a supply curve. In that case, we have said that the supply curve is what? Perfectly what? Elastic. And this, we change this to supply. And in this case, this supply curve would have been what? Perfectly inelastic. Okay. This would have been a unitary elastic supply curve. And as it gets steeper and steeper, it would have been what? Relatively what? Inelastic. And as it gets flatter and flatter, it would have been what? Relatively elastic. Okay, so the same analysis, we have same analysis that we could have done for supply, then because of the lack of time. So you can have something like this. So you know that this is our supply curve as it slopes upward from left to what? To right. So when we have a flatter supply curve like this, it means it is relatively what? Relatively elastic. But when we have a steeper supply curve like this, it is relatively what? Inelastic. So we could have done similar analysis in the context of supply, but because there is no adequate step on our part. All right, welcome back from the break. Let's continue. So as I was saying, some people will come across as people complaining that we don't often apply these concepts at work. So why are you guys taking us through? It's, these are very interesting concepts that you can even apply in your daily life. At work, you have to be able to see how these concepts probably can be applied. They are all from different occupational backgrounds. And so at your workplace, you have to carefully see how some of these things can be what can be applied. The way it will be applied in the pure water production business may be different from the way it can be applied in some other types of what businesses or organizations. So you have to see how some of these can be applied. But in your personal life, some of these concepts can be very valuable. Okay, when you see, sit down, close your eyes, and think about how you can apply them in your personal life, you'll find that some of them actually really can be useful in the interpretation of what happens around you in your personal life, in your buying behavior, in your selling behavior, in your demand behavior. You know, these things can be quite relevant. But you have to sit down and think about how you can apply some of these things to what you do on daily basis, either at work or in your personal life. Okay, so we want to look at the theory of consumer behavior, and we start off by saying that we have all come to understand that the law of demand says that there's an inverse relationship between price and what and quantity demanded. Said that the consumer buys more when the price is less, and buys less when the price is what is high. Other factors being held what constant. The question is, why is the behavior of the consumer as such? We want to understand deeper the nature of the behavior of the consumer. Say that he always wants to buy more when the price is less and buy less when the price is what? And the price is high. To do so, will require us to go through this particular topic, theory of consumer what? Choice or behavior. And to explain or answer this particular question about the law of demand, in other words, the behavior of the consumer to changes in price in the context of demand for a product, there are three main theories under the theory of consumer behavior to answer that particular what question. And these theories that we can use to explain that behavior of the consumer are the marginal utility theory, also known as the cardinalist approach. Then we have the indifference curve theory, also known as the ordinalist approach. And then we have the reward preference what theory. In the course of this particular course, we want to restrict ourselves only to the cardinalist approach and that of the what? The ordinalist approach to explaining the behavior of the consumer. The reward preference is a build up on the indifference F theory. But because we are more interested in the application of these economic theories and concepts, we may not want to go so much into detail explaining all those types of theories that can explain the behavior of the consumer. So let's restrict ourselves to the first two. So I'll summarize the first two to allow us to quickly flip through the slides since we are running out of time, so that if there's still some bit of time, we look at the quantitative analysis of the theory of consumer choice. If there's no time, that will have to be done next week. All right, let's start, shall we? Now we said we have the cardinalist what? Approach, and then we have the what? The ordinalist approach. Now the cardinalist approach tries to answer this question by, in other words, let me start by saying that this cardinalist approach is just a group of economists who decided to answer this particular question about the behavior of the consumer by making certain critical assumptions. And some of the assumptions that they made, so assumptions. But before I come to the assumptions, they say that the utility that the consumer, in other words, the satisfaction that the consumer derives when he consumes goods or services, or goods and services, that utility can be measured. And they say that the utility can be measured in units known as utils, or using money as a unit of measuring individual utility. So either we measure utility in utils or in what? In monetary terms. So that is their belief as a group of economists who think that the utility we derive from consuming goods and services can be what? Can be measured. So let's look at the assumptions that they make in order to do the analysis of the behavior of the consumer. The first assumption is that the consumers are rational. They acknowledge the fact that resources are scarce not only to firms but to consumers as well. And so consumers recognize the scarcity of the resources problem. And so they always want to make it the case that when they spend money on any good, that good will give them adequate what? Satisfaction. And so by doing so, we say that the consumer is what? Consumer is rational. Of course, there are certain exceptions to some of these what? Assumptions. If we hold it wholesomely that the consumer is rational, and so the consumer will only spend money that gives on something that gives him the highest level of satisfaction. There is an exception to that. Sometimes we give people money without anything in return. Are you rational or irrational? Within this context, we will say that you are behaving as a consumer irrationally, but that is not the case. Okay? Sometimes we drive utility also in giving. So when you give people, sometimes you feel what? You feel some kind of satisfaction for being able to help somebody, to lift somebody up. But in the context of what we are doing, they turn that behavior of the consumer to be what? To be irrational. Because they believe that for you to spend money, you must recognize that that money you have is not enough for you. And so spending that money will have to be done in a way that it gives you the highest amount of what? Satisfaction. But sometimes we actually have certain exceptions to some of these assumptions. And they believe that utility is a cardinal concept. We have already looked at that here. They believe that utility is what? It's a cardinal concept. In other words, it's a quantitative phenomenon. We can measure it in units known as what? Utils or what? Or money. So they believe that if you are willing to pay 3 Ghana cedis for this matter, then the utility that you are intending to derive from this matter is 3 cedis. So what you are willing to sacrifice in order to what? Acquire the product is your utility. That measures your what? Your utility. If you are willing to pay 12 Ghana cedis for 18 of Ivory, then your utility in that case is what? 12 Ghana cedis. Because as a rational consumer, you want to spend your scarce resources on product that gives you the highest level of what? Satisfaction. So you are willing to spend on Idiomok by buying it at 12 Ghana cedis. It means your utility from Idiomok is what? Is 12 Ghana cedis. If you want to measure it in monetary what? Terms. According to them, they believe that in the near future, society out of technology will be able to develop an instrument known as a utilimeter, which will help us measure the satisfaction that individuals derive from consuming goods and what? Services. And so using this utilimeter to measure satisfaction, it means we measure satisfaction in units known as what? Utils. But in the meantime, in the absence of that particular utilimeter, we can use money, according to them, as a unit of what? Measuring satisfaction. So the second and the third assumption is that our total utility, U, is a function of the quantities of various goods and services that we consume. So you may consume product X1, product X2, product X3, all the way to product Xn, depending upon the number of products that you consume. So according to them, the total satisfaction that you derive from consuming goods and services equals to the sum of the individual satisfaction you derive from your individual consumption behavior in terms of the various products that you consume. So the sum of the satisfaction you get from X1 consumption and that of X2, X3, and all through to Xn will give us your total satisfaction. 4. They assume that money is a unit of measuring satisfaction. And so therefore the utility of money itself is constant. Money has constant Has constant utility. Money has constant utility. Because they are saying that money is used as a measurement rod or a measuring rod to measure utility. And so it doesn't then make sense for the utility of money itself to be allowed to vary. Please do you understand that? If money is used as a measure of utility, then the utility of money itself has to be constant before it will qualify to measure utility. If you have a rule, we call it a ruler. If you have a rule to measure distance, then the distance of the rule itself has to be constant before the rule can be used to measure distance. Otherwise, the rule, if the distance is not constant and it varies, it extends, then you cannot use the rule to measure distance. Does it make sense? So that's another assumption that they have made, that money has a constant utility. Means that if I give my brother 100 million Ghana cedis, the satisfaction that he will derive from that is going to be 0. It's going to be constant. So no matter the amount I give him, the satisfaction is still going to be constant for the amount of money that he gets. So these are some of the assumptions that the cardinalist school of thought in explaining the behavior of the consumer we have made these assumptions. So let's look at the ordinalists. Just in brief, then we can quickly go through the slide. The ordinalists means that utility cannot be seen, neither can we measure it. Okay, we cannot see utility, we cannot measure it. These others say that we shouldn't even try to measure utility. We should rather think about ordering utility, and that is why they are called the ordinalist school of thought. That we can order utility. In other words, so let me add one more assumption to this. These guys also believe in the law of diminishing marginal utility. They believe that as we consume more and more of product X, for instance, the total satisfaction we get from the additional units that we consume of product X begin to diminish. All right. So back to the ordinary. So that we shouldn't even try to measure utility. Rather, we should think about how we can order utility. If you are offered apples and oranges, cardinalists will tell you that to know which one you prefer is to measure, is to take one apple, take one orange, measure your utility in taking the orange and the apple, and compare the utility. Whichever one is greater, then you prefer that product to the other fruit. But to the ordinalists, they say that is not possible. However, what makes sense and is more practical is that take the apple and take the orange. And based on your satisfaction, you can tell that you prefer oranges to what? To apples, or apples to what? To oranges. So according to them, they have also made certain assumptions. And these assumptions include one, they also believe that the consumer is what? Is rational. Two, they believe that utility is ordinal and not a cardinal concept. Is an ordinal what? Is an ordinal concept and not a cardinal concept. We can order our utility. So if you take TZ and take bamboo, they may look alike, but based on your satisfaction, you can see that you prefer bamboo to what? To TZ, or TZ to what? To bamboo. You don't need to measure the utility and compare, but you can just take them, and based on your feeling, your satisfaction, which one you prefer to what? To the other. The third assumption they have made is also that our total utility U is a function of the goods that we consume. Yes. Any questions? All right. So they also believe that total utility exists, and our total utility depends on the number of commodities or products that we consume. And so the sum of the individual utilities that we derive from the various commodities that we consume. Then the fourth one is that they believe of consistency and transitivity in the behavior of the consumer's demand. Consistency and what? Transitivity. They believe in the law of consistency and transitivity. They believe that the consumer's preferences are what? They are consistent. If the consumer prefers apples to oranges, so will that consumer continue to prefer apples to what? Oranges till thy kingdom come. The consumer cannot prefer apples to oranges this morning, and by later in the afternoon, he prefers oranges to apples. Even though the consumer is very sophisticated in his behavior, if he behaves like that, we cannot study him. So we cannot study his behavior. So we want to make sure that the consumer's preferences are consistent. So you prefer apples to oranges, so you always prefer apples to what? To oranges. Then consumer preferences are also what? Transitive. You have apples, oranges, and mangoes. And the consumer prefers apples to oranges and prefers oranges to mangoes. Then by the law of transitivity in his preferences, he must prefer apples to what? Mangoes. Does it make sense? Yes. So if you like apples to, you prefer apples to oranges, oranges to what? To mangoes. Thank you. Oranges to mangoes. Then by the law of transitivity, you must prefer what? Apples to mangoes. So that is another assumption that they have made. Any questions? So we will now take some time to look at what these schools of thought have demonstrated in ways to explain the behavior of the consumer in a little bit of detail. Do you have time? So you there. Yes. Okay. All right. Thank you. All right. So let's wrap up since we are almost out of time. What is utility? Sorry. We have said that utility is the satisfaction that we derive from the consumption of goods and what? Goods and services. Now we have what we call marginal utility. The satisfaction we derive from additional satisfaction that we derive from consuming an additional unit of a product is what we call what? Marginal utility. Okay. But we also have disutility. If the satisfaction we derive is utility, then the dissatisfaction that we derive is what? Disutility. Disutility. But we have what we call an economic bad, and that gives you this utility. If there's a refuse dam just by your house, in fact, just by your window, the community has a refuse dam just very close to your window. You cannot enjoy the, okay, because it is not a good, it is an economic what? Bad. So the expense will be very high for you to what? To want to like it. And so that gives us a utility. It doesn't give us what? Utility. So we get this utility from consuming an economic bad, then we get utility from consuming what? An economic what? Good. So this gives us utility, economic bad gives us what? This utility. All right. So marginal utility, then total utility. Here it refers to the total satisfaction we derive from consuming a set of goods and what? Services. So let's assume you consume only with X and Y. Your total utility will be the so the satisfaction we derive. What is happening today? Any questions? Okay. So if you consume products X and Y, your total utility will be the satisfaction you get from consuming a given set of units of X and that of what? Y. So we call that total what? Total utility. The total satisfaction we derive from consuming goods and what? And services. Now, there's a relationship between marginal utility and total utility. Our marginal utility is giving us the change in total utility as a result of change in the quantity of a product that we consume. So if you consume apples and you have two apples, you take the first apple, what you get is your marginal utility. Then you take the next apple, the second one. You are going to have another what satisfaction given to you by the second one unit of the apple that you consume. So that additional satisfaction you get from the second unit is what we call what? Marginal utility. So when you take the second unit, you are not going to have total utility to be the sum of the satisfaction you derive from the first unit and the second unit. And so if we try to measure how changes in the total utility results from the change in the quantity that we consume, what we get is what we call what? The marginal utility. Okay, so for increasing your consumption of apples from 1 unit to 2 units, the change in your total utility by increasing the quantity of the apple that you consume is what we call what? It's what we call marginal utility. So if the first unit gives you 2 utils, and the second upon consuming the second unit, your total utility increases from 2 utils to let's say 5 utils. It means that your marginal utility is going to be 5 minus what? 2 divided by 2 minus what? 1. It was in consuming the second unit that your total utility increased from 2 to what? To 5. Okay? All right. So to calculate your marginal utility is to find the change in your total utility. Your current total utility is 5. Your previous total utility was what? 2. Your current units consumed is what? 2 units. Your previous units consumed was what? 1 unit. So 5 minus 2 gives us what? It gives us 3. And 2 minus 1 gives us what? 1. So your marginal utility is going to be what? 3. So that is what we call marginal what? Utility and how it is related to our total utility. Then we have diminution marginal what? Utility. We have already indicated that earlier in saying that as we consume more and more units of a particular product, say apples, the satisfaction we derive from the subsequent units of the apple that we consume will begin to what? To diminish. So this is the relationship between the total utility and the marginal utility. When the units of apples consumed is 0, total utility will be what? 0. And marginal utility will also be what? 0. When the units consumed of the apple is 1, and it gives us a total utility of what? 20. Our marginal utility in that case is also going to be what? 20. Then we take the additional unit, which is the second unit. Our total utility increases to what? 35. What then will be our marginal utility? It will be 35 minus what? 20. That's the additional satisfaction we get from the additional units that we consume. So 35 minus 20 will give us what? 15. When units consumed is 3, total utility is 45. And so our marginal utility will be 45 minus what? 35. And that will give us what? 10. Then you see something here. When we consume the fifth unit, our total utility is what? 50. The same as we had it for the fourth what? Unit. When you consume the fourth unit, total utility is 50. When you consume the fifth unit, total utility is what? 50. It then tells us that total utility has attained its maximum. And so it's at rest now. And if you consume further, it will begin to what? To fall. So the total utility is at its maximum. Total utility will be 50 minus 50, and that will equal to what? 0. And when we consume the sixth unit, our total utility now falls from 50 to what? 45. And our marginal utility will now be what? 45 minus 50, which is negative what? 5. I should make this in exams. Unfortunately, we are not always interested in it. So this is just an explanation of what we have talked about. So this is a diagrammatical representation of that relationship. So when the total utility is at its maximum, marginal utility is 0. When you increase total utility further by increasing, so when you increase your consumption of the product further, total utility will now begin to what? To fall. And as it falls, marginal utility now becomes negative. It now attains or goes into the negative what? Satisfaction territory. In economics, however, there is no economic sense or interpretation for negative utility, negative quantity, and all that. We are just putting this before us to know some to relate to it. That when the utility is negative, it means we are now beginning to see the product not as a good, but as a bad. It's now giving you dissatisfaction when you consume it, instead of giving you what? Satisfaction. So this, however, the nature of the relationship between total utility and our marginal what? Utility. We can use this to drive the demand curve, but we are not actually that much interested in it. Okay. We have looked at this all the time. 10 to 10, 15 we can list. 15. All right. So let's wrap up with this one. Utility maximization. So what we are going through now is the cardinalist school of thought, their approach. They believe that utility can be what? Utility can be measured. So that is what we are going through. Okay. But according to the cardinalist, how then does the consumer maximize utility? At which point do we say the consumer has maximized what? Utility. So let's simplify the discussion for now by looking at a single commodity case. Assume that the consumer consumes just one product, call that product X. At what point can we say that the consumer's utility is maximized? When he consumes only product X. The consumer's utility is maximized when the marginal utility he gets from consuming product X equals to the price he's willing to pay for that particular product, what? X. That is MUX equals the price of what? Price of X. At this point, the consumer is said to be maximizing his utility from the consumption of product what? X. What then happens if the price of the commodity increases? That means we have to be at equilibrium. When the consumer maximizes utility, the consumer is said to be at what? At equilibrium. Where is marginal utility for product X equals to the price of product what? X. But if we are thrown out of equilibrium, the marginal utility of X is now less than the price. In other words, the price increases. What will the consumer then do? Will the consumer continue to increase his consumption of the product or reduce his consumption of the product? The consumer will reduce his consumption because the price is more than what he is now getting from the product. And that is the reality. So as he reduces his consumption of the product, his marginal utility will begin to what? To what? As he reduces his consumption of the product, his marginal utility will begin to what? To rise. Because we are saying that the cardinals believe in the law of diminishing marginal utility. When you consume more and more, your marginal utility begins to what? To fall. Then on the other side, when you consume less and less, your marginal utility begins to what? To increase. So when the price of the product increases, let's say from this was 2 cities, 2 cities, yes, 2 cities, 2 cities. Then the price increased to let's say 4 cities. So utility is now 2 cities. Price is now what? 4 cities. So 2 against what? 4. So as it buys and consumes less and less of X, its marginal utility will now begin to what? To rise from 2 to 3, then to what? To 4. Then the equilibrium will be what? Equilibrium will be restored. All right. On the other hand, if the price just so happens to fall, say that the marginal utility is now greater than the price, what do we expect the consumer to do? To buy more or less? To buy more because the price has what? Has fallen. So this, let's say the price, the utility is 4, and the price was also 4. Now utility has increased to let's say 8. And he's now buying more and more to consume because the price is now less. So as he buys more and more to consume, his marginal utility because of the law of diminishing marginal utility will begin to what? To fall. So it will begin to fall from 8 to 6 to 5 all the way to what? 4. The equilibrium again will be restored. And marginal utility before price will be what? Will be 4. Okay. So this is the case of a single commodity. Any questions? All right. So we'll end here, God willing, and continue next week. Okay. One question here. Yes. Sure, yes. Yes. How does it disagree? Yes. Yes. The preferences for two communities, 2 or more communities, should be consistent. Yes. Not, not, not in that sense. It means your preference for A over B should be consistent. So at all times, you should prefer A to what? To B. It's not about the number of units to consume. It's about which of them you prefer. So you like A more than what? B. So at all times, you must always like A more than B. Yes. All right. Any other questions? So I'll the shares the slides. All right. So the slides have been approved. So you can go through the slides. Then go to the next week when we meet. We'll summarize the remaining part of the slide and look at the quantitative analysis. Thanks for coming. Have a good day. So, yes. I'll do the questions. No, not yet. Next week. But I will be coming. So those who are available can join. See. Right, whatever. Yes, madam. No problem. Then we can go. Yes, yes, I need to hear you. Don't worry. Don't worry. I will you. Don't worry, you will be fine.